Welcome everyone. Let's study today about orbits of artificial satellite, and this is from lesson Space Mission, and this is a part 3 video of this lesson for class 10. So student, in part 2 video of this lesson we have studied that the critical velocity is provided to the satellite to revolve a particular satellite above a particular or fixed orbit. Okay, now let's study today about the orbits of artificial satellite. Alright, so what is the orbit of artificial satellite? First of all, an orbit is a specific path, that is, it may be elliptical or circular around a planet in which a satellite revolves. And the orbit are different for different satellite depending upon the function of the satellite. And depending on the height of the satellite's orbit above the Earth's surface, the satellite orbits the satellite orbits are classified as high Earth orbits, medium Earth orbit and low Earth orbit. So these are the three types of orbits of artificial satellite. Okay, so here alongside you can observe the LEO, that is the low Earth orbit, and MEO, it stands for medium Earth orbit, and HEO means high Earth orbit. So these are the different orbits of a artificial satellite, in which the artificial satellite are revolving around a planet or Earth. Okay, now let's study first about high Earth orbit, or height from the Earth's surface greater than 35,780 km. So student, if the height of the satellites, that is the artificial satellite orbit above the Earth's surface, is greater than or equal to 35,780 km, then the orbit is called as a HEO or high Earth orbit. And a satellite revolving in a orbit, so this is a orbit, it is high Earth orbit, which I have mentioned. Okay, and a satellite revolving in an orbit about 35,780 km above the Earth's surface will take around 24 hours to complete one revolution or one rotation. And we know that the Earth also takes almost similar time, that is 24 hours for one revolution. And if the satellite is revolving in an orbit parallel to the equator, okay, parallel to the equator, the time of revolution for the Earth around itself and that for the satellite to revolve around the Earth being the same, and the satellite will appear to be stationary with respect to Earth. That means the time required for the Earth to complete one rotation, and also the time required for the artificial satellite to complete one rotation or revolution around the Earth is same, that is 24 hours. Alright, so here for a passenger in one vehicle, another vehicle moving parallel to him with equal velocity appears to be stationary, and this is what happens here also. These satellites are therefore called as a geosynchronous satellite. Why? Because these complete their one rotation with respect to in similar time of that Earth. And since these satellites are stationary with reference to the Earth, they can observe a specific portion of the Earth continuously. And therefore these are they are used in application like meteorology and for carrying signals for telephone, television, radio, etc. Now meteorology, that means to forecast the weather, climate of a particular region, these satellites are held. Alright, now next is the medium Earth orbit, or height above the Earth's surface between 2000 km to 35,780 km. Now student, if the height of the satellite orbit around the Earth's surface is in between 2000 km and 35,780 km, the orbits are called as MEO, that is medium Earth orbit. So below side you can observe the orange color orbit around the Earth, that is the MEO. And the geostationary satellite, now geostationary satellite means the satellite which are present in high Earth orbit, okay, orbit above the equator. These are therefore not useful in the study of polar region, and for this purpose elliptical medium orbit, Earth orbit passing over the polar region are used, and these are the polar orbit. And the orbit which are revolving in a polar orbit, it is called as a polar orbiting satellite. And these orbits are called as a polar orbits. In these orbits, the satellite complete one revolution in 2 to 24 hours. And some of these satellites revolve in a circular orbits at a height of around 20,200 kilometer above the Earth's surface. And global positioning satellite. Global positioning means these are the satellite used for the navigational purpose, just to take a time location, to show the time and location of a particular area. Satellites revolve in these polar orbits. Now next is a low Earth orbit, and the height above the Earth's surface is 180 kilometer to 2000 kilometer. Now if the height of the satellite orbit above the Earth's surface is in between 180 kilometer and 2000 kilometer, the orbits are called low Earth orbit or LEO. And the satellite used for scientific experiments and atmospheric studies revolve in low Earth orbits, and depending on the height of their orbits, they complete one revolution in around 90 minutes. So as these are the low Earth orbit satellites, they required minimum time to complete their revolution around the Earth. And here you can observe the Hubble Space Telescope. So Hubble Space Telescope. So International Space Station and Hubble Telescope also revolve in low Earth orbit. Now student, Hubble telescope, these are used to observe the most distant star and galaxies as well as the planets in our solar system. Alright, do you know, student, a group of a student from COEP, that is College of Engineering in Pune, made a small satellite and sent it to the space through ISRO in 2016. So these satellites are known, the name of the satellite is Swayam, and it weighs around 1 kg. So as this is a very small satellite, but this is a very great victory of these students, and a very big achievement also. And the main it is orbiting the Earth at a height of 515 kilometer in the low Earth orbit, and the main objective of the satellite was to provide point-to-point messaging services using a special method. So student, that's it for today's video. I hope you all have understood the orbits of the different different satellite, that is medium Earth orbit, low Earth orbit and high Earth orbits. Okay, let's say thank you all of you.